In this series, we're going to start learning about graphics in Octagon. Whether it's programming circles and squares or writing games, there's a lot you can do with graphics. And the first part of our journey is going to be learning about pixels and displays to find out how graphics actually work. In this video, we're going to look at the basics of graphics, pixels and displays, and coordinates. The first thing to know about graphics is that all of the images and pictures that you see on a screen are made up of pixels. And each pixel is made up of 3 LEDs, or light emitting diodes, that emit light. The first one is red, the second one is green, and the third one is blue. And when combined, these 3 LEDs form one pixel. And a display is basically a collection of thousands or hundreds of thousands of these individual pixels. So basically a pixel is a combination of 3 light-emitting diodes. Colors are generated by mixing or changing the amount of light that comes from each individual pixel. So for example, if all of the RGB LEDs are turned on at the same brightness, you'll get white. If you only have the red one and the green one turned on, you'll get yellow, and so on. And this is how we generate color and how you change the color of an individual pixel. So to summarize, all graphics involves pixels, and each individual pixel is comprised of 3 individual little lights, a red one, a green one, and a blue one, and color is created by varying the relative amount of brightness of each one of the little lights. To get a better idea of how pixels work in reality, we're looking at the screen of my Chromebook, and it's displaying a number of colors. Now the screen of this Chromebook is 1280 pixels wide and 720 deep. And essentially these are all the pixels in the middle here. To us as humans, they look very clean. You can't see the individual pixels because our eyes aren't good enough to resolve them. We can't make out the detail. Just like if you look at a field of grass from 10 miles away, you cannot see the individual blades of grass, but you can see the grass as a whole. So now if we take a microscope and we look at the pixels in detail on the screen, you get a very different view. So here we're looking at the white bar, and that's producing white light. But the microscope on the lower right hand corner is basically showing us that it's not white. What we're seeing are the groups of red, green, and blue pixels that we talked about, rather LEDs that we talked about earlier. So each one of these pixels is displaying an equal amount of red, green, and blue, which means that the result is going to be white. And that's why this particular bar here looks white. And you can see that each pixel is made up of a red LED, a green LED, and a blue LED. So now if we move over to the red pixel, the red bar, we can see that only the red LEDs are turned on for each pixel. Therefore, this particular bar is red. And likewise, if we come over to the green bar, you can see that only the green LEDs are turned on, and they are distinct LEDs. Now, from the human eye's perspective, I can't see each one of these LEDs, but they're clearly there. And then finally, if we look over at the blue, you can see the blue pixels. Now, remember earlier we said that the color yellow was comprised of amounts of red and green. And sure enough, the yellow bar is made up of red and green pixels. And likewise, the purple bar is made up of red and blue pixels. The green ones are turned off. So to summarize, all graphics is about the control of pixels. And each pixel is made up of 3 individual red, green, and blue LEDs. And that's how the images that you see on your screen are generated. by the computer controlling each one of the pixels here so that you see the resulting image. And finally, if I take the microscope and place it in a black area, you can see that it's still black. And that's because for black, all of the LEDs are turned off on all of the pixels in that black area. Now that we know a little bit about how pixels work, the next thing we have to find out is how do you specify which pixel it is on the display that you want to control. So we have here a grid that goes from 0 on the left hand side to 10 on the right hand side, and that's the x-axis. And then we have another left hand side which goes from 0 to 10 down the left hand side, and that's called the y-axis. And each place where these lines intersect is where we can have one pixel. And so what we're doing is we're using the values of x and y to uniquely specify the location of each pixel on this display. Now this pixel has 10 pixels, this display rather has 10 pixels along and 10 pixels down, so that's a total of 100 pixels. So if we take the red pixel, that is 1 along on the x-axis and 1 down on the y-axis. So x is 1, y is 1, so the resulting coordinate is 1, 1, which is an abbreviation for the coordinate of that pixel. So if we look at the blue one, it's 10 along the x-axis and 5 down on the y-axis, so we call it 10, 5, and so on. So basically this coordinate system lets us uniquely specify the position of any pixel anywhere on the screen. And once we've done that, we can turn it on and off, we can change its brightness, its color, etc. So in order to do graphics, you need some way of deciding which pixel it is that you're wanting to control, and that is done by using a coordinate system. In the next video, we're going to look at the show page, which is where Octagon displays graphics. For more information, visit jb.works.